Welcome to today's lecture. Myself, Assistant Professor Tukur Gupta from Ajay Kumar Garg Engineering College, Ghaziabad. The subject I am covering in my lectures is microprocessor and microcontroller. KEC 502 is the code, and this subject is being taught in 5th semester. Today, the topic that I am going to cover is address decoding in 8051. So, why do we need external memory? As we know that 8051 has a limited on-chip RAM and ROM to store the temporary variables and program code respectively. So, it is capable of performing high-level complex operations that require a large amount of memory space. For most normal small applications, the on-chip memory is enough. But if we are using 8051 to implement the higher level applications, or we can say when we are talking about the industrial usage, we need a lot more memory. We can interface a maximum of 64 kilobytes of program and data memory with 8051 microcontrollers. So in this lecture and the subsequent lecture, we will see how to interface this external memory, that is the program memory as well as the data memory, with our 8051. So what is the chip select logic? So the chip select logic is just a simple logic that is developed using additional circuitry to choose one chip from multiple chips. So when we are interfacing the memory units with the memory chips with the microcontroller 8051, then there can be multiple chips available to us, and we have to interface those multiple chips according to our need of memory. So while interfacing the multiple memory chips, multiple memory chips has to be selected, and which memory from among the available ones is to be selected or is to be interfaced. This is decided using the decoder logic, or we can say the chip select logic. So, if we are interfacing more than one chip, they may be program ROM chip or data ROM or even the data RAM, each sharing the same address space range, that is 0000H to FFFFH, and the address lines of the microcontroller has the address 5FFFH on it. Which chip is this addressing refer to? So this we have to check. So the chip select logic enables the microcontroller to answer that question and understand which chip to select for the particular address required to be accessed by the user. So this is the chip select logic. So by considering the available address lines, by considering the amount of the memory which we have to interface, we can decide that how many lines are being used for addressing and how many lines are used to select to make the chip select logic. So the central processing unit provides the address of the location from where the data is desired. This address is in the form of mixture of address lines and some control lines. The decoding circuit is responsible for decoding this information and locating the required memory block based on these signals. All memory chips have one or more than one pins called the chip select pins, or we can say chip enable pins. These pins are commonly active low pins, and we have to activate it to access the chip it belongs. So for every chip, there is the chip select pins, or we can say the chip enable pin, and we have to enable those pins in order to activate that particular memory chip. So the chip select logic is nothing but such a logic of control signals which can activate that particular chip select or the chip enable pin. So in connecting a memory chip to the CPU, note the following points: that the data bus of the CPU is connected directly to the data pins of the memory chip. Control signals read and write from the CPU are connected to the output enable and write enable pins of the memory chip. In the case of address buses, while the lower bits of address from the CPU go directly into the memory chip address pins, Okay, so this is simple. The lower order address buses pins are directly interfaced with the connected to the memory chip address pins, but the upper ones are used to activate the chip select, or we can say the chip enable pin of the memory chip via an additional decoding circuitry, and this is known as the chip select logic, as I have already discussed in the previous slide. So in order to define the chip select logic, there are different ways to generate this logic. So first one is the simple logic gate. Next is the 74LS138, that is the pin name, and that is the chip name of latch IC. And last one is the programmable logic. So as a note, we must see that we have to remember that the goal of the chip select logic is to create an output for a certain set of input values that activates the chip via chip select or chip enable pin. So what we have to do, we have to just make an output for a certain set of input values. So we have to create the input values, we have to create a logic in such a way that the input values are given to those logic circuitry, and the output must enable the chip select pin. That's it. So this is what is defined as the chip select logic. Now, so let's see the first category, that is using the simple logic gate. So the logic gates decoder circuit, if the chip select, that is the CS pin, for active high, we would have used AND gates. So this we have to take care that if the chip select logic, that is the chip select pin, is active high, we can use the AND gates to make the chip select logic. But if it is active low, then we have to use NAND gates. Then only our logic will be easier to implement. So for the example, A15 to A12 must be 0011 according to this. I'll explain it in order to select the chip. This results in the assignment of the address 3000H to 3FFFH to this. So how is it possible? See, all the lower order data lines, that is the D0 to D7, are directly connected to data lines. Lower order, so we know that this is 4K memory. 4K memory means 2 raised to power 12. Yes, 2 raised to power 12 is 4K. It means 12 address lines are used. So see, A0 to A11 address lines are used to implement the address bus. Now we are left with the 12 have been used here. So we are left with the 4 address lines. Yes, total 16 we are having in 8051. So we are left with the 4 address lines. These are used here. So these left address lines are used to make this chip select logic. See, we know that this is active low and we have to make it 0 to activate this chip. This is the memory chip. So we have to activate this chip, and to activate this chip we have to make it low. So how is it possible? This line will be low if all this is high. Yes. Yes. So when all these lines are 1, 1, 1, 1, all 4 are 1, then only this is 0, because this is NAND gate. We can see this is the not over here. So this, when all these are 1, then only we are able to obtain 0 here. What is the condition when all these are 1? A12 is 1, A13 is 1, A14 should be 0, and A15 should be 0. That means 0, 0, 0, 1, 1 must be given to A15, 14, 13 and 12 in order to select this particular memory chip. Now, how we will make the memory map? So in this way, A15 to A10 we can A0 we can write. So we are talking about the starting address and the ending address. So when we talk about the starting address, 0, 0, 1, 1, 0, 0, 0, 0 up to A0. Again, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1 up to A0. So in this way, we can define the starting address and the entering address. That is the range of the addresses which can be interfaced or which can be accessed using this logic, using this memory chip. So this was implemented using this gates. Now, another way of making this chip select logic or selecting this memory IC is the decoder circuit. So 74LS138 is the typical decoder IC where 3 are the inputs, that's A, B, C, and there are 8 active low outputs, Y0 to Y7. We connect each of the Y outputs to the chip select of a memory chip, yes, allowing us to control over 8 memory blocks. Since we are having the 8 outputs, so by using 3 inputs A, B, C, we can control or we can select or deselect any of the 8 memory chips connected to the controller. So the inputs to the A, B and C activates the output. Also there are 3 additional inputs, G2A, G2B and G1. So these 3 inputs are used to enable the decoder chip IC. So G2A and G2B are the enable inputs and are active low. G1 is also enable input pin, that is active high. So we have to note that G2A and G2B are active low and G1 is active high. If any one of the inputs G1, G2A or G2B is not connected to any address lines, they must be activated permanently, either Y, VCC or ground, depending on the activation level. So what is being said in this point, that if we are not left with any address lines which can be used to make the chip select logic, then since we know that enabling these, activating these pins, we can activate the decoder circuit, decoder IC. Since this is active low, so to activate these can be permanently connected to ground, and to activate this, it can be permanently connected to 5 volts. So in this way, we can also permanently activate these pins. Let's see. So this is the 74LS138 decoder IC. And ABC are the 3 inputs. These are the 8 outputs. VCC and ground are given for the activation of this IC. This IC has to be enabled. These are the enabled pins, G2A, G2B and G1. So in this way, now here again 4 kilobytes of memory chip memory is being interfaced. So for this we require 12 address lines. So 12 address lines are being consumed here. We are left with the 4 address lines. So we can use these 4 address lines. 3 are used as inputs A, B, C. We are left with the 1 address line. That 1 address line can be used to activate the G2A. Again, G2B and G1 are left. So G2B can be permanently grounded and G1 can be connected to VCC. In this way, this IC is enabled and it gives the outputs according to the input provided to the IC. Now, since we can see in this diagram that the chip enable pin is being connected to the Y4 of the decoder, Y4 output of the decoder. So accordingly, we have to give such a combination at ABC according to the decoder truth table that this Y4 pin should be activated. So in this way, the ABC inputs. So in this way, ABC inputs are given the required inputs, and similarly A0 to A11 can be defined, and similar the data is sent through these lines. So this is the way of using the decoder IC. Again, as I have already discussed in the previous slide, thus in this way the memory map can be defined for this logic. Now, last way of defining the chip select logic is programmable logic as a decoder circuit. There are different types of programmable logic devices like PAL, GAL, etc. And these are the electronic components used to build the reconfigurable digital circuits. PAL is programmable array logic, GAL is gate array logic. So as we can see that there is an array of AND gates and OR gates, and according to the technology used, that is whether it is GAL, GLA, PAL, PLA. So these can be made programmable or non-programmable according to the technologies. And in this way, the combination of the AND gates and the OR gates are used to make the decoder, to make the chip select logic. So, like PAL or the programmable array logic is the PLD. That is, the PLD is programmable logic device, which consists of the reprogrammable AND logic and a fixed OR logic connected together. The advantage of these chips is that they are more versatile since they can be programmed for any combination of address ranges. One disadvantage of these chips is that one must have access to the PAL software and burner, whereas the 74LS138 needs neither of these. So this was the advantage with the decoder that we studied here, that there was no need of such burners and all softwares or the burner programs. So in this way, this was decoder was simpler to use. And in case of the limited number of memories, ICs, we can simply use the gates logic. But if we have to interface more and more number of ICs, suppose up to 8 in number, so we can easily connect 8 at a time, 8 ICs, memory ICs, using this decoder logic. So this is better than programmable logic devices. So the various control signals and the ports used to interface 8051 is pin number 30, that is the ALE pin. As we all know that this pin is used to latch, that is the demultiplex the address from the multiplexed address and data bus. PSEN, that is the program store enable. This pin is connected to the output enable pin of the ROM to enable the access to the data. It's an active low output signal, and it's used to enable or read the external program memory. So when it is 0, then external program memory becomes enabled and microcontroller reads the content of the external memory location. So that's why it is connected to the output enable of the external ROM. And when this is 1, the data cannot be read from any external program memory, and the microcontroller has to depend on the on-chip ROM to store the program code. Another important pin is external access pin. It's connected to the ground to indicate that the code is stored completely in the external program memory, that is 64 kilobytes of external program memory. But if we are using both on-chip ROM as well as the external ROM together, then this pin is connected to the 5-volt supply. So this we have to know that if this pin is connected to the ground, then it means that we are not using any on-chip memory. We are dependent on entirely on the external memory. But if this pin is connected to 5 volts, this means that we are working on both internal and external ROM. The overline represents the active low operation, that is turns on when the low pulse or signal is provided. Read, that is a P3.7 pin. Read is used as a read control signal pin. Write, P3.6, this is used as write control signal pin. Another important features are port 0 and port 2. We all know that port 0 is used as the lower order address bus, and the port 2 is used to interface higher order address bus in case we are using the full address bus. So these were the important pins which are used in interfacing the external ROM or RAM with the microcontroller. So in the subsequent lecture, we will study how to interface this external ROM or RAM with the microcontroller. So we will look into it. That's all for the day. Thank you.